Completing the square, 6.3. Now we're going to complete the square to turn the standard form equation into the vertex form equation. So this all still using the same stuff that we learned from the other two lessons, but we're going to write it in a different way. Instead of it being set equal to 0, it's set equal to the function, either a y or f of x, okay? The first thing we have to do is get rid of that 70. Because just like in the last problems, this value for c, this c, does not work. Now, the difference is when you move it, it's not just going to be a 70 over there. What you're going to now have is f of x minus 70 equals x squared plus 16x. Okay, so now we have this. Next, we need our new c. We need the term here that we just needed in the other ones. So we do the same thing we did before. You take that middle term, you take that b, split it in half. Take that number and square it. That's your new c. So we are going to add 64 to make it a perfect square. Now remember, if you add something to one side, you got to add it to the other. So you're also going to add 64 over here. What you're going to be left with looks like this. F of x minus 6, because negative 70 plus 64, there's a difference of 6, equals x squared plus 16x plus 64. Now this is a perfect square. Okay? So we should write this as a perfect square in factored form. We should write it as x plus 8 squared. That's what it should look like to show it's a perfect square. X plus 8 squared. Now, one last thing. To make it look like this, the number at the end is in the wrong place. This 6 should be over there. So how are we going to move a minus 6 with inverse operations? We're going to add 6. But you can't add numbers inside the parentheses. The parentheses kind of have this on lockdown. They can't get out, has to stay in. So the only place you're going to put that 6 is next to it. So your final answer for this function in standard form to change to vertex form is this. F of x equals x plus 8 squared plus 6. That's our answer. Now, also, to identify the vertex, it wants the h and the k. So, what is the h and the k for this? Well, the h is negative 8. I know it's weird, but think about it. The formula needs a negative sign, but they don't have a negative. They had a positive. How do you change a negative sign to a positive when you plug in the number? The only way to change it to a positive is by plugging in another negative. So when you plug in a negative 8 in here, negative negative makes it positive. The 6 is just 6. That's my vertex. And those are my two answers. There's the vertex form of the quadratic equation. There's the actual vertex. Okay? Let's do this a couple more times. Let's do this one on top. Yeah. Again, I'm going to move that 5. Don't want it there. Inverse operations. So now we have f of x minus 5 equals x squared minus 6x. Now I need my c. Take that, split it in half. Take negative 3. We're going to take negative 3 and we're going to square it. We get 9. So my perfect square number for there is 9. But because I'm adding a 9 there, I'm also adding a 9 here. So now I get f of x plus 4 equals x squared minus 6x plus 9. Okay, I want to write this as a perfect square, so I'm going to do it in factored form. X minus 3 squared. Okay, the last thing I have to do is move this number 4. I got to move that 4. Inverse operations. Okay, it's not going to go in there. It's going to go over there because you can't mix it. So your answer for this, your new function, is x minus 3 squared minus 4. My vertex has a minus sign. So remember the minus sign is there from the beginning. That minus sign isn't the number. That minus sign is part of the equation. Your h is just the number 3, a positive 3. The k, however, is this number. That's been changed to a negative, so that makes that negative 4. And that's your vertex. All right, so vertex form and vertex. Now let's show you one that's a little bit more complicated. If you guys remember, sometimes there's numbers in front. So we have to deal with that. But before you do that, let's move this C out of the way. Let's have this C move out of the way. All right, now you have this. Now, in the last problems, I told you we divided everything by 6 and we canceled it out. I don't want to cancel it out. I want to factor it out. And the difference is the 6 is going to stay there, okay? Because in vertex form, sometimes there is a number in front. And that number is the factor that you take out right here. So right here, what is the factor for these two things? 6. So just the term, not the x's, we're going to leave the x alone, just the 6. That would make this that. All right, now we're still going to need a c to make it a perfect square. But now instead of dealing with 12, we're dealing with this. This is my ax squared plus bx plus c. So 2 is the number I'm splitting in half. I take that number and I square it. So I'm adding 1 in here. Now, here's where you have to be careful. That 1 is being affected by this 6. Because it's inside the parentheses, this is being affected by a 6 times 1. Okay? So, what you're really doing here is you're adding 6 times 1. Not just the 1, 6 times 1. So this is going to be negative 13 plus 6. Negative 13 plus 6. Your new function is going to look like this. F of x minus 7 equals 6 x squared plus 2x plus 1. All right? I know it's confusing, but the reason is it's not just the 1 in here anymore. That 1 is being multiplied by 6. So the real number in here, you're treating it like a 6 times 1. Okay, this we should write as a perfect square. So we're going to write it as x, not x squared, x plus 1 squared, 6 outside, f of x minus 7. Almost there. What do we have to move? The 7. We got to move it back, but not here with the 6 and not inside the parentheses, but at the end. So what happens? Your new equation in vertex form is 6 parentheses x plus 1 squared plus 7. And your vertex is negative 1, 7. There's my vertex. I know it's a lot. This is why I'm doing a few examples so that people can see it done multiple times, but also take your time. Take your time. Do not rush through these, all right? Okay. Now here. Luckily here they already moved the c, so you don't have to do that. Just have to deal with this. Now if you notice, it's a negative 9. Okay? So if it's a negative 9, I'm going to treat this a little bit differently. Okay? I'm going to say I'm going to divide this by factoring out -9 from both of the numbers, okay? So -9 is going to be factored out. And let me see. That'll leave this as x squared. Now this is where it's going to be a little confusing. Negative divided by -9 will make it positive. And 162 divided by 9 is 18x. Again, I'm going to leave some space in here for my perfect square. Okay, but I didn't cancel it out. And because I didn't cancel it out, I don't have to do anything over here. The 9 is still there. All right. Now, we got to come up with the c term. So we go to our new b, which is in 162. Now it's just 18. 18, split it in half. Take that number and square it. That is my term, 81. Now, you're not going to add 81 here because remember, the -9 is affecting the 81. So what we have to do is we have to take that -9 times 81, and you get this, 731 minus 729. That subtracts. We're going to get f of x, sorry, I should do it in black, plus 3 equals -9 x squared plus 18x plus 81. Okay, I'm just going to keep writing it down because I'm running out of space over here. So I'm going to write this as a perfect square. So it'd be x plus 9 squared. All right. Almost there. We're going to move that 3 using inverse operations, but not over here, not over there. Over here. So now our function f of x equals -9 x plus 9 squared minus 3. And there's our vertex form. Now our vertex, our numbers, would be a -9 for h and a -3 for k. That's my vertex. Change the sign. This was a negative, it became a positive. This was also a positive, it changed to a negative. So if they changed the signs, that means they plugged in negative numbers.